So what the fuck is the deal with Solana anyway? An introduction to the Solana blockchain. This post is intended to give a rundown of Solana for curious technicals. I assume you know how computer work. On comparisons to Ethereum to explain some things, but comprehensive as knowledge is not important to make sense of this. I am not gonna explain proof of stake, but feel free to Google Byzantine fault tolerance and Geb theorem if you want some pleasant light reading about a CS problem that is not complicated or annoying at all. This post may be of some interest to non-technicals, but I am gonna be honest, it's probably too jargony. Nevertheless, if you can't find something via Google, you can be like, what does X mean on Twitter, and they'll probably tell you unless it's too complicated. Most of this post is me summarizing the Solana docs. I think the material in them is very valuable and comprehensive, but it's probably adapted from someone's notes or something. In particular, it's not organized into dependency ordered chapters. I.e., if you read in order, some stuff in earlier sections is incomprehensible until you read later ones. I got high and binged the entire thing in one day, flipping back and forth as needed, so now you don't have to. Everything in this post is 100% true and correct unless something changes or someone tells me I am wrong, in which case I will silently edit the post to be right and my claim of infallibility still stands. To put it in a sentence, Solana is a proof-of-stake blockchain plus some extra shit. The most important extra shit is a mechanism they call proof of history. Validators are constantly hashing the previous output of a hash and periodically publishing one of those hashes plus the number of iterations required to reproduce it. This is cool because you must produce new hashes in serial, but you can verify a collection of hash checkpoints in parallel. The hash chain is canonical across validators, but validators can produce them independently without needing to wait for committee blocks. These hashes are used as a rudimentary clock, to be able to prove things happened in a certain order, and that some arbitrary amount of time elapsed between them. Sharing a clock simplifies some of the woefully complex coordination problems inherent in blockchains. Most of the other extra shit is straightforward optimizations. People love to trot out the marketing terms Solana uses for these and attempt to explain them in detail, but for our purposes it's not really important. We'll just summarize. Validators use not BitTorrent to fetch blocks and don't need to wait for all the pieces to presume correctness. They also claim to offload data to not Filecoin, so validators can run like clients, but someone in their Discord told me they never implemented that, so IDK. Instead of flood-filling the mempool tiers deterministically dead selection and nodes forward transactions to future layers. The client declares what memory locations it needs beforehand so that runtime can prefetch and map it. They run multiple transactions on the same program in parallel with same instructions. They offload signature verification to us. That's basically it. Solana uses AT25519 for encryption and SHA-256 for hashing. They chose SHA-256 specifically because all the effort put into BTC ASICs means it's unlikely to have a surprise optimization that would trivialize proof of history. Pubkeys are used as addresses without truncation. There's an Easter egg that you can use base 64 for supposed perf improvement, but everyone uses base 58 anyway. Solana likes to claim in its marketing material that it is way faster with zero trade-offs. This claim is stupid. It is very true that Solana optimizations are legit, often very clever. It's not like BSC, which just cranks up some numbers and kicks their can down the road. But what is being traded against, dear developer, is your time and your sanity. Much of the complexity that Solana requires to achieve the TPS it does is simply placed on your doorstep. Compared to Ethereum, the system is much more complicated and difficult to reason about, and much must be done by hand. I think this trade-off is fine. The chain is really fast. It's worth it. But it's better to be honest about it rather than try and pretend it doesn't exist. In time, a lot more of this will probably be abstracted over. Anchor does a good job already of normalizing the client chain interface. But you had better understand what's going on underneath it, or you're gonna be for pain sooner or later. I am absolutely convinced the reason Solana has not had any scams or runs of nodes other than weak press lore (PND) bullshit is because scammers are not smart enough to build for it yet. This will change. One of the reasons I want to write about Solana is because very few Solana devs seem to have a red team mindset. I am gonna write a lot more about this kind of stuff in particular soon. Programs and accounts. practical difference Solana has from Ethereum is that it very aggressively separates code and data. This has a number of implications for how the system is structured, and accounts in particular are the biggest source of confusion for Ethereum devs coming to Solana. Programs are stateless contracts. There's nothing like class variables or globals or whatever you get in Solidity. All data is explicit patched by reference from the outside. You write programs in Rust with the Solana SDK library. There's a thing called Zargo to cross-compare it to EPF. You just need an extra config file for that. Cargo build, BPF, and the deploy command will be displayed to you after. There's a built-in program upgrade feature. Accounts are buffers. I don't know why they call them accounts, it confuses the shit out of everyone. There's a function create account. It's calc on the blockchain, I swear that's all it is. You create an account with a declared size in bytes and can store arbitrary binary data in it. Accounts cannot be realized. But now that I think of it, I haven't checked yet if you can recreate them after freeing them. That's an interesting question. Accounts can also store LAM ports, the coin name for the Solana coin's smallest unit. In theory, you pay rent for storage, but if you put 2 years' worth of rent in the account, then they let you be exempt, so everyone just does that. An account is owned by the system program by default. The system program has basic functions for creating more accounts and sending LAM ports and such and such. Accounts can be assigned new owner once and only once. This owner is always a program, which has permission to download LAM ports from the account and modify its data however it wishes. Account addresses are at 25,519 pub keys, and the corresponding private key is retained by the user for signatures. Solana devs like to call this authority to avoid adding a confusing second meaning to owner. Programs are not special, they are also data, stored in accounts. These accounts are flagged as executable and ownership is transferred to an Webflow program. Program accounts are required to have enough lamps to qualify for rent exemption. And I think you can't delock them either. Various places refer to a program ID. This is just the address of the account it's stored in. One advantage of the program account model is you can have one generic program that operates on various data. The best example of this is the SPL token program. To create a new token, you don't need to deploy code like you do on Ethereum. You create an account that can mint tokens, and more accounts that can receive them. The mint address uniquely determines the token type, and these are all passed as arguments to one static program instance. Transactions and instructions. The basic operational unit on Solana is an instruction. An instruction is one call into a program. One or more instructions can be bundled into a message. A message plus an array of signatures constitutes a transaction. This is very important for Ethereumers to understand, and users can construct atomic transactions that call multiple programs. I don't think anyone really appreciates the security implications of this fact yet, but it will adore many exploits YouTube introductory paragraph someday. I won't bore you with a full binary spec. The important thing is you must forward declare every account you intend to read from or write to. That may include the system program, the token program, your accounts, your token accounts, any necessary program accounts, etc. This also includes special addresses called scissors if the program needs to know facts like how much is rent or what time is it. This is the cost of their prefetching and parallel execution optimizations. I promise you that you will learn to hate this, especially since the accounts are passed as an array, so you need to get the order right.
What?
Especially since the accounts are passed as an array, so you need to get the order right.
What?
Especially since the accounts are passed as an array, so you need to get the order right. Writing to an account requires the authority to do so, which is proved by signing the full message with the appropriate private key. Non-signed accounts may also be readable. For instance, if found by the program your instruction calls. A transaction is uniquely identified by its first message signature. The last important thing a message contains is a block hash, which is what it sounds like. I specifically say message to communicate that it is part of the signed data. It serves the same purpose as Ethereum nonces.
What?
The last important thing a message contains is a block hash, which is what it sounds like. I specifically say message to communicate that it is part of the signed data. It serves the same purpose as Ethereum nonces. The last important thing a message contains is a block hash, which is what it sounds like. I specifically say message to communicate that it is part of the signed data. It serves the same purpose as Ethereum nonces. The block hash is also used as a TTL by requiring it be no more than 3 blocks old. This means if the transaction isn't confirmed in a certain amount of time, it can never be confirmed, and you can safely regard it as expired. Solana also provides a nonce mode for those who want it to enable air-gapped signaling. Program-derived addresses. There's a special kind of accounts which a program can sign for without a private key. Given a set of arbitrary bytes plus a program ID, you can generate what looks like a 25,519 pub key. As long as it is not a valid key, i.e. not on a curve, there's a mechanism for Solana to fake a signature for you. The reason for not invalidity check is to ensure a private key by definition cannot exist. This ends up being kind of annoying because not every combination of siege and program ID is usable. There's special functions to take them and increment and nonce until you get a invalid pub key for. Programs want to be able to sign accounts for cross-program invocation. And if you want your program to transfer labs to a user account, you can have the program sign its own account and invoke the system program with its account as the from address and the user account as to. A common pattern is to use addresses derived from a namespace and a user pub key for efficient key value mappings, keyed of the user. Runtime. Solana really earns the mainnet beta designation once you get into runtime constraints. Every instruction has fixed compute budgets which cannot be exceeded. There are hard-coded limits on above instructions, like messages, stack size, code depth, and number of cross-program invokes. Reentrancy is banned except for self-reentrancy. You get 32 KB of heap and no free or real lock. There is no mechanic to pay for more compute, so if you can't fit in the budget you better make it fit. I live in terror of writing a working program that calls another program, and later its dates change it to be more expensive. And now my program can't fit in budget anymore and breaks forever. There is also a 1232 byte limit on messages, which is egregiously low. Because of the very strict compute budgets, CPI is for in and out type of stuff, not for Legos. In theory, you use multi-instruction transactions for that. But in practice it's hard to fit complex operations into the size limit because you need to list bajillion addresses for everything. There's talk of a new transaction form act coming that may or may not improve this situation. Clients submit transactions and fetch data from RP PC nodes using Saruk payloads sent to 8899. There's also a pop-up website that shuts 8900年 but I haven't used it yet. One thing that takes some getting used to is the fact that, unlike Solidity, programs have no read interfaces. Write only? If you need to read, you have to pull the raw data by count address via RPC and deserialize it yourself. Client submit transactions and fetch data from RPC nodes using Saruk payloads sent to 8899. There's also a pop-up website that shuts 8900年 but I haven't used it yet. One thing that takes some getting used to is the fact that, unlike Solidity, programs have no read interfaces. Write only? If you need to read, you have to pull the raw data by count address via RPC and deserialize it yourself. Solana website doesn't have any documentation other than TypeScript types, but there's enough string references to be in there. I think I might be forked from the ETH equivalent. IDK send and confirm transaction is usually the function you want. This is not a programming tutorial, but I will warn you that forming proper transactions is tricky. Look up some examples and good luck. The most important debugging advice I know that no one ever told me: turn on pre-flight checks when testing client code, turn them off when testing on-chain programs. Transactions are sanity checked on the client before they're submitted, but the errors and logging you get from the chain are way better. There's options object that you can pass into the send functions for this. Also, for local testing, you can turn commitment down to process so you don't have to wait for confirmation to see result. In contrast with the somewhat arcane client-side experience, the click tools are really good. Show the Solana install version manager and we're set up. Solana test validator does exactly what it says, and literally you just have to run that and it works. I love it. Solana logs gives you logs which you can print to in programs with MSG. There's a lot more, but seriously I have no complaints here and it's all very straightforward. Calling convention. This is my favorite part. All Solana programs expose a single entry point that provides as arguments the program ID, accounts array, and instruction data. What's instruction data? That's right, baby, a UBA array. Serialization and dispatch are your problem. If you are calling someone else's program, you have to rely on them giving you client code or documentation to be able to determine how to properly form the instruction, because all interfaces are opaque and ad hoc. Anchor. This isn't Anchor tutorial, but you'll see it's pretty cool. The main benefits are it imposes the dispatch table interface similar to Solidity, handles serialization and deserialization for you, and lets you pass accounts as objects instead of arrays. I've been using it some, but I don't have enough experience yet to explain how to use it really well. But you better learn the stuff it's extracting over first or you'll judge you super hard. Conclusion. Congratulations, now you know Solana. Well, JK, but I think this is a good overview to have a strong vibe on how it differs from Ethereum, and I solid this to learn how to get on it without being like what the fuck is this, what is that all the time. I hope you enjoy my ramblings. This is not the last you've heard from me. My next post I think will be things about Solana to make you go HMM, in which I muse about various exciting attacks only possible in the world of Solana land, along with evil ways to try and work around their resource limits, and various other manner of exciting things. For fun and profit.